Formative 4. So this formative is all about transformations. On that first problem, our parent function is g of x equals 12 to the x. So we don't want that 12 to throw us off as being a vertical stretch. The 12 is part of the parent function. So that little x as the exponent, anything done directly to that x in the exponent, that would be considered as inside parentheses. So for example, maybe I could rewrite this as 12 to the x in parentheses. So anything done directly to that x is how we would normally have it in the parentheses with all the other types of transformations and functions we've done in the past. So on part A, that negative sign in the front is a reflection over the x-axis. The -4 right here, that would be considered inside the parentheses. So those are always our horizontal translations. And since it's a -4, we actually want to go right 4. In part B, the x plus 2 is in the exponent, so that would be considered inside the parentheses. So it's always the opposite of what we think it should be. So the plus 2 means we're actually going to go left 2. And then our plus 7 is being added to the function, so it's not inside the parentheses. So that's your vertical translation. And vertical translations are as they should be. So up is positive, down is negative. So you would go up 7. On part C, the negative sign in the front is still a reflection over the x-axis. And then the 1/8 is being multiplied by the function. So that's basically our a value from off of the notes. So if the a value is greater than 1, that would be a vertical stretch. If the a value is in between 0 and 1, that's a vertical compression. So 1/8 is in between 0 and 1, so that would be a vertical compression. And then in the back there, that -11 is a vertical translation down 11. On number 2, they already have a graph of f of x shown for us. So we just want to do a new sketch of this new graph and then talk about the key features of the new graph. So let's figure out what's happened here. So the negative sign in front is the reflection over the x-axis. The plus 2 is inside parentheses, so that would be a horizontal translation, and they're always the opposite of what we think they should be. So that would actually be left 2. And then the plus 4 would be up 4. That's a vertical translation, up 4. So the key with this problem, when I look at the original function that's already graphed for us, there would be a vertical asymptote that I'm drawing in right now at x equals 0. So that would be my vertical asymptote at x equals 0. So I need to take that function and I need to flip it over the x-axis, which basically means I'm turning it upside down. And then I also need to go left 2 and up 4. So I can see on the graph, there is a point right here at 1, 0. So that's going to kind of be my point that I shift around. So I'm going to take that red dot and I'm going to change colors. Let me do this pink color. So I want to go left 2 and then up 4. So that red dot is going to go left 2 and up 4. So it's going to be right here. And then as far as the vertical asymptote goes, it needs to move left 2 as well. So it's currently at x equals 0. So if I move it left 2, now it's over here at x equals negative 2. And actually, let's write that in for our asymptote off to the right hand side. X equals negative 2. And then when I actually draw in my graph, I don't want to draw it the same curve. I have to draw in the curve upside down because of the reflection over the x-axis. So it's basically going to look something kind of like this. And then we want to label it m of x so we know which one's which. So for the domain of m of x, we don't really have any x values less than negative 2. So my lowest x value is going to be negative 2, and then all the way up to infinity for my domain, because those are all the x values that pink graph covers. And then for the range, negative infinity to positive infinity, because this pink graph here is going to keep going down ever so slightly as you go to the right, and then it's going to keep going up. Over here on the left, it's going to keep going up. So all the y values will be covered eventually.